These are the notes we took in class today, and it involved taking a closer look at the area of a circle. The essential question, how do you find the area of a circle? Okay, so what I started off with is I already know that you have memorized the formula, or you should have memorized the formula for the area of the circle, and we all know that it's pi times the radius squared. However, I don't really want you just to memorize it. I wanted you to know how that got derived, like how did they even come up with that? Because all the other areas for stuff we've talked about so far make sense, like the area of a rectangle or a square, it's length times width. So for example, if like, this is completely off, but if that was, if that side of the classroom was 20 feet and this right here was, let's say, I don't know, 10 feet, just to make it easy to multiply, then I would know that there would be 200 square feet composing my floor, okay? So that makes sense. Also with triangles, area of triangles, that makes sense. So if I took like, if I took this room and I cut it diagonally in half, I know I would have to go length times width and divide it by 2 to get the area of a triangle. But with circles, it's not as kind of common sense really. So that's why I want to show you how they even came up with that pi r squared. And a really good video that will help you kind of visualize this, that's way more detailed and way better than the notes I'm going to show you about how to derive it, is here. Here's the actual YouTube channel, because I want to give this person credit. And if you're like, I can't read this handwriting, you can search area of a circle, and then there was a comma there, how to get the formula, period. And it was posted by Mathematics Online, okay? So I'm gonna do kind of a quick little, I don't know if this is gonna work. Let's see it. Okay, we're gonna try watching it. It's only 2 minutes and 46 seconds.
Pi r squared gives you the area of a circle. But where does pi r squared come from? First, we'll draw a circle and fill in its area. Next, we will divide it into large equal parts and arrange them in a rectangular formation. As you can see, it barely resembles a rectangle. So next, we will divide the circle into small equal pieces, and we will arrange them in the same manner. You can see that it appears more like a rectangle. So if we divide the circle into even more smaller pieces, you can see that every time the shape becomes more like a rectangle. So how small must we divide a circle before we can get a perfect rectangle? Well, we can keep on dividing the circle into small, smaller, or the smallest pieces you can make. But the answer is to divide the circle infinitely many times until we cannot distinguish the lines, and eventually the circle can now become a perfect rectangle. So, the area of the circle is equal to the area of the rectangle, which is equal to base times height. The height of the rectangle, as you can see, is the same as the radius. So height is equal to radius. To find the base, we need to look at the circumference of the circle. And when we compare the base and the circumference, we can see that the base is equal to 1/2 the circumference. Remember that the circumference is equal to 2 pi r. When we combine it with 1/2, the 2's cancel out, and base is equal to pi r. So now, base times height becomes pi r times r. Combine the r's together, and we have pi r squared, which is equal to the area of the rectangle, which is equal to the area of the circle. So pi r squared can be used to calculate the area of any size circle that exists.
Okay. So I'm going to do what that guy did, and I didn't really have the willpower to divide that up into the skinny little slices he did, so I'm not going to do that. So I just divided mine up into 12, and you'll see that when I created its rectangle, it doesn't look like a perfectly nice rectangle, but you should know that if you cut it up into skinny, super skinny slices and you lay them all like this, then you would have, you know, a rectangle. So first thing that we did to go from here to here is I just basically turned that circle into a rectangle by cutting it up and then aligning it like that, okay? So we turned the circle into a rectangle. Darn it. Okay. And I know that they're totally equivalent because I literally took another piece of note paper and I cut that out and I put it right there. So I know that this is an accurate representation of this, that these would have the same exact areas, okay? Look at this. I have to put that back. Okay. It's hard to do things one-handed. So anyway, what the dude said in the video basically is the distance. Okay, let's start off with, let's back up the train here. Okay, we turn into a rectangle, and we all should know that the area of a rectangle is length times width, or you could say base times height, same thing. Okay, and we know that that's going to be the length times the width, okay? And looking at the length right here, I see that the length, make the length, see how it is one, it's all the edges of those white, like triangle slices. So when I look up here back to, in relation to the circle, I know it's right here. This right here is the length of that rectangle. And the distance all the way around is the circumference, but this is only half the circumference. So this little, this length is half the circumference. Okay? And we know, or you should know, you should have this memorized, that the circumference can be derived by doing 2 times pi times the radius, okay? Okay, and then that would give us that length. And we have 1/2 times 2 times pi times the radius. So I'm going to write that here. 1/2 times 2 pi r. Okay, that's the length right there, okay? And we know we got to multiply that by the width to get the area of that rectangle. Well, the width, right there, that's the radius. See, it's right there. I'm going to label that for you, if it lets me write. Okay, so the length times the width is the radius. I'm just going to call it r for radius. Okay, let's go ahead and just simplify this. I see, what's half of 2? Half of 2 is 1. So this right here is really like 1. I'm going to do a sideways 1. Okay, that's 1. So 1 times pi r is pi r. And we got times it by that radius. So that area of that rectangle, you know, which is based off the circle, is equal to, let me simplify this, pi times radius squared. And that's also the area of any circle. Okay? So you don't have to, I don't think you have to memorize that for like any testing or assessments, but that's more than the average person knows about area. So if you ever ask somebody on the street and say, what's the area of a circle? They're going to probably say pi r squared. But if you ask them, how did they come up with that equation? They probably just say, oh, just because my teacher told me to memorize it. So this just shows you where it comes from, how we derive this area of a circle, okay? So down here, here's the area of the circle. This is what you have to memorize. But that is what it is, how we got it. Pi times radius squared, okay? Let's go ahead and do some practice problems over here. And I want you to make sure you're rounding your answers to the nearest hundredth, okay? Round them to the nearest hundredth. If it doesn't come out as a whole number or whatever, round it to the nearest hundredth. So if you have some sort of decimal, make sure it's to the hundredths place, okay? That's really important because on the SBAC testing, if the answer was supposed to be like, I don't know, 3.14, and it said to round to the nearest hundredth, that should have been your answer. But if you yourself rounded to 3.1, they would mark that wrong, okay? And I know that because when some people took their interim tests, they rounded it incorrectly, even though, you know, they technically had the right answer. They marked it wrong. Okay, so I don't want those silly little things to dock you. All right, so find the area of a circle that's got a diameter of 10 centimeters. So I'm just going to draw just a quick sketch here. The diameter is all the way across. It's 10 centimeters. So that would mean the radius is 5. And let's start off with the formula for area of a circle. Pi, area is equal to pi times radius squared. Area equal, okay, and oops, I don't know why I just did that. I'm trying to rush because in about 5 minutes I'm supposed to go sub for another teacher. So I'll probably have to splice this video. Okay, the radius is 5. Okay, so when you're solving it from right here, you don't want to go, oh, pi times 5 and then square it. No. You need to remember the order of operations. Order of operations says that you got to do grouping symbols first, and I don't see any, then exponents, so that 2 is attached to that 5. So 5 squared is 25. Then after you do the exponents, you got to multiply and divide from left to right, and then after that you can add and subtract from left to right. But I see there's multiplication right here. This actually is the most accurate answer, 25 times, the real pi. However, the directions say to round to the nearest hundredth. And I don't care if you use the pi button on your calculator or 3.14. On the SBAC, they'll tell you what to use, okay? They might even tell you to use this to represent pi, because that's pretty close to pi also, okay? But this is a rational number, because it can be written as a fraction. So anyway, 25 pi is approximately 78 and 54 centimeters squared if you use the pi button on your calculator. If you did not use the pi button on your calculator and you use 3.14, you would probably get this. Okay, so this is using 3.14, this is using the pi button. Either one would be completely acceptable. But on the SBAC or NUIA, use what they tell you to use. They might tell you to use 3.14, or they might tell you to use this, or they might tell you to use the pi button on their calculator that they provide on the screen. Okay? All right, so I'm going to try to somehow splice this together because I got to go to the other classroom. All right, bye. But hi again because I'm going to play it together. Number 2, a circle has a radius of 7 centimeters. What's its area? So it gives us this information right here that the radius is 7 centimeters and we're looking for its area. Okay, so I'm just going to draw a quick little sketch over here to help my brain figure that out. The radius is 7 centimeters. So we are looking for the area, so I'll write down that area formula. Okay, pi times radius squared, oops, the radius is 7. Okay, so when I'm looking at this, 7 squared is 49, so the area is equal to 49 times pi, and that's going to be approximately, if you use pi in your calculator, 153 and 94 hundredths centimeters squared. If you're someone that used 3.14 times 49, you would have probably gotten this if you rounded it to the nearest hundredth. Okay, and you'll see that it's a little off right there, but they would still both be correct. And again, whatever it says on the SBAC or the NUIA, whatever it says to use for pi, that's what you use, okay? So if they say use 3.14 to represent pi, that's what you do. If it says to use the pi button, use the pi button. And if it says to use 22/7, use that, okay? If a circle has a radius of 7.5 inches, what's its circumference? So it's given us this radius information right there, but it's asking for the circumference. So a quick little sketch right here. The radius is 7.5 inches, but they want to know what's the distance all the way around right there. They're looking for the circumference, given this information. So there's 2 ways, well, there's probably a couple more ways than that, but there's 2 ways that I've shown you to find the circumference. And one of the ways was, for those people that are really good at just memorizing formulas, circumference is 2 times pi times radius. And you would just take your information and just substitute it in. We don't know the circumference, so keep it a variable. 2 times pi, and the radius is 7.5. So 2 times 7.5 is 15. So the circumference is equal to 15 times pi, which is approximately 47 and 12 hundredths inches. It's not squared because it's the circumference, okay? Or if you use 3.14, you'd have gotten 47 and 10 hundredths inches. Okay, so that's one of the formulas that you can use to find the circumference. Another formula, and this might be helpful, this might be the formula that some other students memorized, because in the class activity where we were measuring circumference and dividing it by diameter and you're supposed to get pi, some people might remember that formula better. So circumference divided by diameter should equal pi every single time. And when we were measuring in class, when you were taking the circumference of a circular object and dividing it by its diameter, Some of you weren't getting exactly pi, and that's simply because either the item wasn't a perfect circle or we measured it just a little bit, tiny bit off. But many kids in the class are fairly close to 3.14159, blah, 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 okay? So anyway, we don't know the circumference, so I'm going to keep that a variable. The diameter, the diameter. I don't see the diameter in here, but I do know that the radius is 7.5, and the radius is half of the diameter. So if I want the diameter, I'll just double the radius. So 7.5 doubled is 15. So the diameter is 15 inches. And when I take the circumference divided by the diameter, I should get pi. Well, here's just your standard equation. You need to solve for the variable, solve for c. So the opposite of dividing by 15 is to multiply by 15, and you'll do that to both sides of the equal sign. Okay, 15 divided by 15 is 1. 1 times c is c. And c is going to equal pi times 15, or 15 pi is how most people would write that, okay? Which is exactly what we got over here. When you go 15 times pi, the pi button on your calculator, you would get approximately 47 and 12/100 inches. If you use 3.14 on your calculator, you would get 47 and 10/100 inches. Same thing. I think I don't have enough room. Okay, so either one of those is acceptable. Okay, the area of a circle is 36 pi inches squared. What's its radius? So they're saying that you got a circle and the number of squares in there, there's 36 pi inches squared. There's 36 pi that are inch by inch little squares in there, okay? So we're supposed to find its radius. They give us this information. Okay, so this is where you just kind of got to use what you know to help you solve the problem. The area of a circle is 36 pi inches squared. Gosh, I know the area formula for a circle. It's pi r squared. That's the area, and it's telling you the area is 36 pi. So the area formula would give you the area right there, okay? See how like up here, we got the area is equal to that? Well, pi r squared equals 25 pi, or 78.54 centimeters squared. Here, there's your area formula, and it's going to equal this, okay? Typically, we'd go 36 times pi, 36 times pi to get that. But they probably didn't want that repeating decimal and stuff, so they were like, oh, just keep it like this, okay? So anyway, we want to solve for the radius. We want to get the radius all by itself. So here's what we will do. To solve for it, let's go ahead and start off by dividing both sides by pi. Okay, think about this. What is pi divided by pi? And if you can't think of that right away, think about something easier. What's 27 divided by 27? Well, that's 1. What's 2 divided by 2? That's 1. What's negative 5 divided by negative 5? Well, that's 1. So, what's pi divided by pi? It is 1. Okay? 1 times r squared is r squared. I'm going to write that over here. Okay? So this is right there. Okay, oh look, it's pi divided by pi. Pi divided by pi is 1. 1 times 36 is 36. Okay? So right here you got to be thinking, what number multiplied by itself, what number squared will give you 36? And if that doesn't come to your brain right away, the inverse operation, which is a fancy word for the opposite of squaring something is to square root it, okay? All right? So when you take a number and square it, and then take the square root of it, you're left with just plain old that number, okay? The square root of 36 is 6. So the radius is 6. Well, now you're going to take that radius and use it to help you find the circumference. And remember up here, you had this option to use or this option to use. I'm going to show you both ways for both of my types of learners out there. So circumference is equal to 2 times pi times the radius, or you can do this one right here. Circumference divided by diameter is always going to equal pi. So I have the radius right here, times 6. So my circumference is going to be 6 times 2 is 12, and then times that by pi, which is going to be approximately 37.70 inches. And it's just inches because we're just looking for the circumference, okay? Circumference of that. It's not going to be inches squared because inches squared would be area. All right, if you're a person that used 3.14 for pi, you'd probably get this, okay, like that. Okay, By the way, let me know if I've made any mistakes, because there's a chance I probably did somewhere. All right, so the circumference we don't know, so we'll keep it a variable. The diameter is double the radius. Double the radius is 12. Okay, so to solve for C, we're going to multiply by 12 over here, multiply by 12 over here. 12 divided by 12 is 1. 1 times C is just C. There's only one C there. And pi times 12 can be written as 12 pi. That's your exact answer. But if you're going to use the pi button on your calculator, you would get 37 and 70/100 inches. But if you use 3.14, you would get 37 and 68/100 inches. Okay? Look, the same exact answers. Okay, what's this circle's area? It's giving you a drawing right here. They're giving you the radius, so you need to know that that is the radius right there. So start with your formula. Okay, the radius is 1.5. And you're going to go 1.5 times 1.5, and you're going to do that first. Do not go 1.5 times 2. That's wrong. This is squared. 1.5 times 1.5. It's going to give you 22 and 25/100. Don't forget to multiply it by pi. Okay, and that's going to be approximately, if you use the pi button on your calculator, 7 and 7/100 centimeters squared. Or if you use 3.14, it's the same thing. Okay, they ended up rounding the same. Okay. Okay, for your summary, in number 5, what's the circle's diameter? So what's the diameter of this circle? All right, this next problem, it says a sprinkler rotates in a circular pattern and sprays water over a distance of 18 feet. What is the area of the circular region covered by the sprinkler? So it's spraying water over a distance of 18 feet. So here's a little example. I Googled like an aerial view of a sprinkler. And I don't know if you could see it. Okay. I'm going to show you to give you the hint. All right. So imagine that this is all the area that's getting, oh, the picture's moving. This is the area that would be getting wet by the sprinkler. So is that right there? Is that a diameter, a radius, or a circumference? Okay. Look at that. It's going to go out 18 feet. Is that a radius, a diameter, or circumference? Think about that, okay? Okay, so what you should have gotten is that would represent the radius. So if I'm drawing there's my sprinkler, it's going squirt, squirt, water, water, and it's squirting it all the way around, you know? So that right there is the radius, and that's represented by 18 feet, okay? So now we got to find the area of all that stuff that gets wet, okay? So all that area that's getting wet. So, start with your formula. Pi, the radius squared. Okay, so your area is going to be 18 squared is 324 times it by pi. That's the exact answer, but remember we're supposed to round it to the nearest 100th. So if you used the pi button on your calculator, this would be your approximation. If you use 3.14, you'd get this. Okay. Okay. Number 7, what's the area of a semicircle with a diameter of 18 centimeters? We're looking for an area. The diameter is 18 centimeters, and it's a semicircle. Okay, so I'm going to draw a sketch of that. And the diameter all the way across, remember diameter, is 18 centimeters. So the radius is equal to 9 centimeters, all right? So the area of a half circle or a semicircle is pi r squared divided by 2, okay? So let's go ahead and substitute those numbers in. Pi radius is 9 squared, don't forget to divide by 2, okay? So this right here, 9 times 9 is 81, pi divided by 2, okay? So you should get, when you go 9, or 81 times pi divided by 2, or you can go 81 divided by 2 times pi, same thing. 81 divided by 2 is 40.5 pi. And when you do that in your calculator, you would approximately get 120, if you use the pi button, 127 and 24 hundredths centimeters squared. Or if you used 3.14 for pi, you would get 127 and 17 hundredths centimeters squared, okay? What's the area of a quarter of a circle with a radius of 6 centimeters? So a quarter of a circle, that means a fourth of a circle, okay? And they're asking for the area, and it's got a radius of 6 centimeters. So assuming it was a whole circle, the radius would be 6 centimeters. That could have been worded better, okay? So that's 6 centimeters. This is what it looks like. So area of a quarter circle is, okay, you take the area of the whole circle and then divide by 4. Okay, and then substitute your values in. So pi, the radius is 6, you got to square it, and you got to divide it by 4. So this would equal 36 pi over 4. I can go 36 times pi, press equals, and divide by 4. I can go 36 divided by 4, which is 9. And then don't forget your pi. And you would approximately get 28 and 27 hundredths centimeters squared, or if you use 3.14 as pi, you would get 28.26 centimeters squared, okay? This is using the pi button on the calculator. This is using 3.14 because some calculators that you have at home maybe don't have that. All right, the circumference of a circle is 24 inches. What's the area of the circle? Okay, they give you that the circumference is this, and they're asking for the area. Here's another one where you got to really use what you know, okay? They're saying that the distance all the way around this circle is 24 pi. So from there all the way back is 24 pi, okay? And they're asking for the area. So use what you know. So I should start 2 pi r is equal to the circumference. Okay? So 2 pi r, and they're telling us that the circumference is this. Okay? And they're looking for the area of the circle. This doesn't give me the area, but I can find the radius and then figure out the area. So to get the radius all by itself, I'm going to divide both sides by 2 pi. You could totally divide both sides by 2 first, and then divide by both sides by pi, but this is faster. 2 pi, okay? What's 2 pi divided by 2 pi? It's 1. 1 times r is r, okay? What is 24 pi divided by 2 pi? Well, this right there turns pi divided by pi is 1. 24 divided by 2 is 12. So your radius is 12, okay? But if you're like, oh, you know what? I don't like this circumference formula. I'm one of those people that likes this formula. Circumference divided by diameter equals pi, okay? But they're telling you, hey, the circumference is equal to 24 pi, okay? And do we know the diameter? Nope. But we know that the circumference divided by the diameter will equal pi. So let's go ahead and let's solve for d. But the d is on the bottom, so we're going to multiply both sides by d. Okay, d divided by d is 1. 1 times 24 pi is 24 pi. And that's going to equal pi times the diameter. Okay, I want the d by itself, so I'm going to divide by pi. Divide by pi. Pi divided by pi is 1. D times 1 is d. Pi divided by pi is 1. 24 times 1 is 24. The diameter is 24. The radius is 12. Isn't the radius half the diameter? So if the diameter is 24, the radius will equal 12. Okay? So we get the exact same answer. But we're not done. They want the area. So here's where you would take pi times radius squared is equal to the area. Or you can go area equals pi r squared. Okay, so area equals pi times the radius squared. Radius squared, 12 times 12 is 144. So 144 pi, which is approximately 452 and 39 hundredths inches squared. If you use the pi button on your calculator, if you use 3.14, you'd get 452.16 inches squared, okay? So let's take that same thing over here. Again, area equals pi r squared. Same exact thing. There's our radius. Okay, and you'll get the same exact answer if you prefer this method. Oh, that's for using the pi button, and this is for using 3.1415, okay? I mean 3.14. For your summary, I want you to answer this question. What's the formula for the area of a circle? Be sure that you remember to fill out the back right here. If you don't fill it out, you won't get points. Fill it out, turn it in. Okay, bye.